Hey guys, it's Mr. Ray here with our next lesson in grade 11 University Math. We are working in the exponential functions unit, and the first three lessons of this unit we're just looking at the use of exponents and how to simplify expressions or equations so that you can combine and work with different types of exponents. So the first lesson we reviewed all the exponent rules, the product rule, the quotient rule, and the power of a power rule. And we also talked about negative integer exponents. So if you had 2 to the power negative 3, what does that mean? It's hard to interpret because normally you'd multiply the base that number of times. So multiplying 2 by itself negative 3 times does not make sense to us. So what we actually do is we take the base, which is 2, and we take the reciprocal, flip it upside down. So the base changes to 1/2, and then we change the exponent to become the positive version of what it was before. So 2 to the power negative 3 is the same as 1/2 all to the power 3. And we also learned that anything to the exponent 0 is always going to be 1, except for that one case. 0 to the power 0 is actually undefined, so we can't calculate that. Okay, so today we finished working with integer exponents. We've covered all the possible integer exponents. What if the exponent is a rational exponent? In other words, like a fraction. Okay, so before we get started with this, we got the normal definitions here from last lesson. So rational exponents have a lot to do with roots. For example, if I had, say, the square root of x, because it's square root, I can actually rewrite this with a rational exponent. That's the same as x to the 1/2. Okay, so these go back and forth. So I can convert either direction, whether in what other situation makes the most sense for me. Okay, now if I continue this, well, what about the cube root of 3? Cube root of 3, cube root of x is the same as x to the power 1/3. And so this continues on. You can see the relationship between, so square root, we don't usually put a 2 here. It's kind of by default, but square root you could write like that with a 2 in the little pocket there. So whatever the root is on the bottom of the fraction. So square root of 2 is, square root of x is x to the 1/2. Cube root of x is x to the 1/3. Fourth root of x is x to the 1/4, etc. Okay. That's where we get fraction exponents. As soon as you see a fraction exponent, you know that the bottom part relates to the root we're taking. Okay, so let's get into the concepts here. Just wanted to explain that quickly before we dive in here. So hopefully this makes sense now. A number raised to a rational exponent, a fraction, is equivalent to a radical. So a radical is like a root. The rational exponent 1 over n, so like we had 1/2 and 1/3, it could go on forever, indicates the nth root of the base. So just like we said, the square root is the second root, the cube root is the third root, etc. If n is greater than 1 and n is a natural number, then b to the 1 over n. 1 over b to the n is the nth root of b. So this is going in the other direction, converting the 1 over a number fraction exponent into a radical. So that's the other conversion direction. Okay. Now what happens? So that kind of covers what any rational exponent that's 1 over a number. You kind of understand what that means now. But what if it's a fraction that's like let's try this right now. What if it was x to the 2/3? Maybe I'll do that here. X to the 2/3. Well, what does that mean? Okay, now what we always do, and this is the best way of understanding, we can break apart that exponent into the numerator part and the denominator part. So I always do the denominator part first. So if I can consider 2/3 to be the same as 2 times 1/3, okay, and so I could write this as x to the 1/3 and then the whole thing to the power 2. So this is really the power of a power rule going backwards. Okay, if I gave you this, you would say, oh, we just multiply those two, and it would create 2/3. But you can also just take the fraction apart into its numerator denominator. So the top part of the fraction would be the integer power, and the bottom part would be the radical, the nth root. So in this case, the third root. Okay, now so that I could then rewrite that as the cube root of x, and then just square that answer. So converting x to 2/3 is the same as that. Now I could also look at this maybe instead. Let's do it a slightly different way. So instead of putting the 1 over n part in the brackets, what if I just switch the order? And I said, well, let's do the squaring first and then the root part. So you can see I've just reversed the order I put the numerator denominator parts of the fraction. So here you could say, well, we're going to square x. So I'm going to square x first, and then I'm going to take the cube root of x squared. So you can see there's actually two versions of what x to the 2/3 means. I could take the cube root of x first and then square that result, or I could square x first and then take the cube root of that. So the order doesn't matter in terms of the upper or lower power of the fraction. I find when you're evaluating fractions that the first part, this would be the preferred method, that you actually take the root first and then square it, because if you square the number first, you're going to get a pretty big number, and then try to get the root is usually more difficult, not for the calculator, but for our minds. Okay, so that's what this part here is. If the numerator of a rational exponent is not 1, and m and n are positive integers, then b to the power m over n is equal to the nth root of b all to the power m. So you can see I did the process the 1 over n first, or it's also equal to b to the power m, and then we take the nth root of that. So you can see these are the two options we talked about here. So either one's acceptable. It's just usually this version is a little more workable. Okay. All right. And on most of your calculators, you have a power button where you can choose different powers, and also usually a root button where you can insert the correct root, whether it's the cube root or the 6th root. So look for those on your calculators. Make sure you're able to do it, because some of these we can't do in our heads. Now here's one thing we talked about, odd roots. If I take, for example, I take the cube root or the 5th root or the 7th root, so that would be considered an odd root because, 3, 5, and 7 are odd numbers. You can actually take the cube root or the 5th root of a negative number. For example, I could take the cube root of -8. You're looking for the number. What number do I multiply by itself 3 times to get -8? Well, the -2 works for that. Okay, so if you're taking an odd root, you can take the odd root of positive and negative numbers. But if you have an even root like 2, 4, 6, like the square root, you can't take the square root of a negative number. It just does not work. There's no number that you can square that gives you a positive result. So that's important to know. So cube root, 5th root, 7th root, you can apply that to negative numbers, but square root, fourth root, sixth root. You can't take the root of a negative number for that. Okay, and just a reminder, any expression raised to the power 0 is equal to 1. So we did that before. Okay, so let's do a little bit of practice here. Let me zoom in a little bit. Okay, so the first question is 49, and it's a little hard to read here. That's to the negative, actually that's to the 1/2, sorry. 49 to the 1/2. Well, we know that 1 over 2 of an exponent, that's really the same as the square root. So I can replace the exponent 1/2 with the square root symbol and just put the base inside. So that's the square root of 49, which is equal to 7. Okay, now here we have the exponent 1/3. So 1/3 represents the cube root. So I'm going to change that exponent 1/3 to be represented by a cube root. And this is exactly the example I just talked about. The cube root of -8. You can do this on a calculator, of course, but it's good to understand what you're actually getting. So if I'm taking the cube root of -8, I'm asking what number do I multiply by itself 3 times to get -8? And you know it's going to be negative. Okay, and you can just play around with it. It's not 1, because that would be, cube root of negative. If I cubed -1, I just get -1 again. If I cubed -2, I will get -8. So the cube root of -8 is -2. And here we have 10,000 to the power 1/4. Well, 1/4, I can rewrite that as a fourth root. So that replaces the 1/4 exponent. And then I put 10,000 here. One too many zeros. So it's not 10,000, it's 1, 2, 3, 4. It is, it is 4 zeros. So we want the fourth root of 10,000. So we're looking for what number do we multiply by itself 4 times to get 10,000. Well, after a while you realize, well, it looks like it's going to be 10 or 100 or something. So 10 times 10 times 10 times 10, that gives me 4 zeros, which is exactly what this is. So the answer to this is 10. And you can also check your work. If I put this to the power 4, I should get that number. Just like if I put this to the power 3, I should get that number. If I put this to the power 2, I should get that number. So that's a way of checking. Now we've got some exponents that are not just 1 over a number. In this case, we've got 27 to the power 2/3. So I'm going to rewrite. First, I'm going to break apart the exponent into its numerator denominator. So like I mentioned earlier, so I'm going to put 27, and then the bottom part, so the 1 over 3 I'll put first, and then brackets around that, and then that's going to be squared because the numerator of the exponent is 2. Okay, so I'm going to do it in this order. You could actually reverse these two. You could square 27, which is a big number, and then try to take the cube root. That's going to be tough. If you change the order, you probably won't be able to do this in your head. Okay, so if we do it this way, I'm basically saying, okay, the 27 to the power 1/3, that's just the cube root of 27. And whatever that is, I'm going to then square the answer. So the cube root of 27, after a while you get good at these, I know that's 3. So this thing in brackets is equal to 3, and then I'm going to square it from the square here. So that's equal to 9. So that was definitely something I can do in my head. Whereas if I did it the other way, I'd have to do 27 squared first and then take the cube root. For both of those calculations, I would need a calculator. I have no idea what 27 squared is, and even less idea what that number is, the cube root of that number would be. So it's always good to do the denominator part first. All right, so here we have -27 to the 4/3, so similar to what we just did. Now notice we got brackets around the -27. That's important because it's saying that the base here is negative 27, it's not 27 to the 4/3 and put a negative sign in front of the answer. Very important. That says that the base is negative 27. So I put brackets just around the base, and then I put the 1/3, and then I'm going to put another set of brackets with the power of 4. I know there's lots of brackets, but brackets a lot of times will help you understand it better. So don't be afraid to use brackets to make it clear for yourself. Now this middle part inside the outside brackets, that's negative 27 to the 1/3. That's going to be the cube root of negative 27. So that's everything inside these outer brackets, and then whatever that is, I'm going to put that to the power 4. So if I think about what number do I multiply by itself 3 times to get negative 27, I know that's going to be negative 3. Negative 3 times negative 3 is positive 9, times another negative 3 is negative 27. So that's what I get inside the bracket, and then I'm going to put that to the power 4. So negative 3 times negative 3 is 9. And then if I multiply by another pair of negative 3s, it'll be 9 times 9, which is 81. Okay. Don't be afraid to use your calculator on these, but you should also try to understand, try to figure it out in your head first, and then check with your calculator. Okay, this next one's a little different because we don't have a fraction exponent, we have a decimal exponent. Now, I never talked about, well, what do we do with decimals? Well, what we're going to do to decimals is turn them into a fraction. So 0.75, I could rewrite that as, well, 0.75 is 3/4, so that would be negative 3/4. Okay, and for the first time, we have a negative fractional exponent. So what do we do now? Well, the first thing we do is we process the negative part. So the fact that that's negative means I'm going to take the base, which is 16, I'm going to flip it to its reciprocal, so 1/16, and then I'm going to apply the exponent but change it to positive. Okay, it's important we do it in the correct order. Process the negative exponent part first, and then process the fraction parts. Okay, so again, at this point, I can break this apart into the 4 denominator and the 3 numerator. So I'm going to have 1/16 to the power 1/4. And then that result, I'm going to put that to the power 3. So you can see if I multiply these two, I'm going to get that. So, but this is telling me the 4th root of 1/16. I'm going to get that and then cube the result. I think I'll use a little bit more room here. So what happens when you're taking the root of a fraction? So it's kind of the same as when we had an exponent for a fraction. We actually apply the root to both the top and the bottom. So sometimes, you don't always have to do this, I'm just going to break this up so that I apply the 4th root. So the 4th root of 1 on the top and the 4th root of 16 on the bottom. Sometimes students find that a little easier to process. So I can take the 4th root of 1, that is equal to 1, and the 4th root of 16. So what number do I multiply by itself 4 times to get 16? That would be 2. So there I get my result of, and I could have gone directly from here to here if you understand what you're doing, but you're really taking the 4th root of both. What I don't want you to do is go on a calculator and figure out what 1/16 is as a decimal and then take the 4th root. Okay, so I still have to, oh, I forgot my cube there. So now I cube 1/2, and cubing is the same as taking the root. So this is really the same as 1 cubed over 2 cubed, which is 1/8. So final answer, 1 over 8. Again, you don't have to break it down like this, but if you want to understand how did I go from here to here, well, it's really 1 cubed over 2 cubed. Okay, seems to we're a little bit tight on the focus here. All right, the last question, last example. This one looks like a bit of a nightmare. You've got 8 to the 5/6 times the square root of 8 all over 8 to the 5/3. Well, the good news is, it looks like 8's the common number here, and basically it's 8 to a power, 8 to a power, and we're going to convert the square root into 8 to a power as well. So let me give ourselves a bit more room here. So I'm going to rewrite. All I'm going to change in the first is I'm going to change the square root of 8. So I'll keep the other ones as they are, 8 to the 5/6 and times 8 to the 1/2, because the square root of 8 can be written that way. And then on the bottom I've got 8 to the 5/3. Now the good news, like I said, all the bases are 8, so I can use the product rule and quotient rule here. The bad news is, well, I'm going to be I want to add these two together and then subtract that one because of the quotient rule, but these are all have different denominators for their fractions. So what do we do if we want to add, subtract fractions that have different denominators? We come up with a common denominator. So we do the same thing here. So I see denominators 6, 2, and 3. That means I should choose 6 as my lowest common denominator. So I've got 8 to the 5/6. Now I want to convert 1/2 to something over 6. So 1/2 equals 3/6. And if I want to convert this exponent 5/3 to something over 6, well, I just double the top and bottom. That's going to be 8 to the power 10 over 6. So now we've got the same base of 8. We've also got all our fractions with the same denominator. So now we just combine them all together. So I'll do that in one step. You can do it in two if you'd like. So if I apply the product rule to the top, so it's 5/6 plus 3/6. And then the quotient rule part says I'm going to subtract 10/6. Okay, so now we just figure out what that result is. I got 5 plus 3 is 8. 8 minus 10 is -2. So 8 to the -2 over 6. Okay, and here's something we should do with fractions as well. Try to reduce the fraction as much as we can. So in this case, 2/6 is the same as 1/3. I can divide the top and bottom by 2. So I've got 8 to the -1/3. Okay, so I'm going to need some more room here. Now, again, we've got the situation with a negative fraction exponent. So we're going to handle the negative part first. When we handle the negative exponent, we flip the base. So the new base is 1 over 8. And the new exponent is the positive version of -1/3. So it's 1/3. And now I can write this, change this back to a radical. 1 over 3 as exponent means I'm taking the cube root of 1/8. So again, if you have to, you can split the numerator and denominator so that you take the cube root of 1 over the cube root of 8. Or if you don't need to do that, that's perfectly fine. Cube root of 1 is 1. Cube root of 8 is 2. So that is the answer. So hopefully this helps you understand how do you deal with rational exponents. They go back and forth. You can see this one here. We wanted to have the same, I can't really combine these until I change that radical sign, the root, into a rational exponent, the 1/2. Okay, so you have to do that first. You want to have the same properties so that you can combine them together. And then once you've combined them all together and reduced it, well, once you get down to this stage, this is when you change back to the radical part, because this is where you actually do the calculation. Everything from here to here was simplifying our expression to something simpler that we could actually process at the end. Okay, so I've got some homework questions for you to work on, and hopefully that makes sense. The next lesson, we're going to not really learn too much new. I'm just gonna throw a bunch of much more complicated expressions to simplify. So it'll be practicing the skills you've just learned today and on the previous unit. Okay, so hopefully that makes sense, and we'll see you on the next lesson. Take care.